Alright, welcome to the solutions of practice assignment 1 of statistics 2. So we'll start with the first question. So they have given a joint distribution table for x and y. Now a and b are unknowns and we have to find the joint distribution for x and y. Right, so to begin with, firstly we have to start finding the value of a and b. So we can easily find out that by using this relation, which is sigma fxy is equal to 1, right? So the sigma fxy is nothing but the summation of all these elements, so that is nothing but 1 by 12 plus 3 by 12 plus a plus 2 by 12 plus b plus 1 by 12 plus 3 by 12 plus 1 by 12 plus 1 by 12. That should be equal to 1. So by adding it all up, so we'll get 1 plus a plus b is equal to 1. So it means that a plus b is equal to 0. So since a and b cannot be negative, so we can conclude that a is equal to b and that is equal to 0, right? So now so they are asking us to find out p of y is equal to 1. So what are all the values where we get p of y is equal to 1? Y is 1 here. So if we sum all this row, we'll get p of y is equal to 1, right? So to do that, so p of y is equal to 1 is nothing but 2 by 12 plus b is nothing but 0 plus 1 by 12. So that is nothing but 3 by 12. That is the answer. So next question, p of y is equal to 1 given p of x equal to 2, right? So this is nothing but whatever that is given should be in the denominator, that is p of x equal to 2. Okay, so in the numerator we'll be having p of y is equal to 1 comma x equal to 2, right? So that is nothing but basically this term p of x equal to 2 and y is equal to 1. X equal to 2 and y is equal to 1 is nothing but 1 by 12. So we'll just substitute that here, 1 by 12 in the numerator, and p of x equal to 2 is nothing but a plus 1 by 12 plus 1 by 12. So we have to sum the column where x is equal to 2, right? So this is nothing but 1 by 12 divided by 2 by 12, so that is nothing but 1 by 2. Okay, so next question. So p of x equal to 0 comma y is greater than or equal to 1. So this is nothing but p of x equal to 0 comma y is greater than or equal to 1. So I'll take y is equal to 1 here plus p of x equal to 0 comma y is equal to 2, right? So these are the only two possible values. So by summing it up, we'll have 2 by 12 plus 3 by 12, and that is nothing but 5 by 12, right? So next question. So x is given, x is uniform 1 2 3 4 5 6. Let y be the number of times 2 occurs when x throws of a fair die. So right, so first we'll just understand the question. That is nothing but we'll be choosing one of the number from this, right? So for example, if we take 5, x value will be 5 right now, and 5 times we have to throw a die. So in that 5 times, what is the number of times we will get 2? That is the question, right? So what do we have to find out? So firstly we'll go option by option, that is p of y is equal to 2 given x equal to 2. Okay, so this is nothing but x equal to 2, so we have chosen this number, so we have to throw a die 2 times, right? So that is nothing but a binomial of, or how many number of times that we are throwing, that is 2, and what is the probability? That is 1 by 6, right? So this is nothing but 2c2 and 1 by 6 to the power of 2 and 5 by 6 to the power of 0. So that is nothing but 1 by 36. Now going with the second option, that is P of y is equal to 2 given x equal to 4 is nothing but, again, so we have x equal to 4, it means that we are throwing the die 4 times. So it means that we'll have 4c2 and 1 by 6 to the power of 2 and 5 by 6 to the power 2. So this is nothing but 4 into 3 divided by 2 into 1 into 1 by 36 into 25 by 36. So that is nothing but 25 by 216, right? Okay, the next one, P of y is equal to 5 given x is equal to 6, and now that is nothing but 6c5 into 1 by 6 to the power of 5 and 5 by 6 to the power of 1. It is nothing but 6 into 1 by 6 to the power 5 into 5 by 6. So 6 is cancelled, so this is nothing but 1 by 6 to the power 5. Okay. The last one is P of y is equal to 6 given x equal to 5. Sorry, into 5 is there. Okay. Now, so they are telling us x is 5, so it means that we are throwing only 5 times, right? So can we get 6? No, right? So the range of y is nothing but 0, 1, 2, 3, 4 and 5. So if we are throwing a die 5 times, we can expect number of times that we are getting 2 is only 5. We will not be getting 6, right? So this question is invalid. So the incorrect options are the last option, that is this one, and the first option, right? So next question, we have let let the random variables x and y each have ranges 1 to 3. The following formula gives the joint PMF. Okay, P of x equal to I, comma y equal to j is equal to I plus 2j by c, where c is an unknown value given. So we have to find what probability of x greater than or equal to 1 and less than or equal to 3, and y greater than 1 and less than or equal to 3, right? So now, so we have to find out what is the value of c first. So to do that, we'll just use the formula, that is sigma p of x comma y is equal to 1, right? So what are the different possible values here? So p of x equal to 1 comma y is equal to 1 plus p of x equal to 1 comma y equal to 2 plus p of x equal to 1 comma y equal to 3 plus p of x equal to 2 comma y equal to 1 plus p of x equal to 2 comma y equal to 2 plus p of x equal to 2 comma y equal to 3 plus p of x equal to 3 comma y equal to 1 plus p of x equal to 3 comma y equal to 2 plus p of x equal to 3 comma y equal to 3, so that is nothing but 1. Okay, so if we substitute in this formula, so we'll get 1 and 1. We have 3 by c plus 5 by c, this is c, sorry, 5 by c plus 7 by c plus 4 by c plus 6 by c plus 8 by c plus 5 by c plus 7 by c plus 9 by c, that should be equal to 1. So finally we'll have 54 by c equal to 1. It means that c is equal to 54, right? So what's the probability of 1 less than or equal to x and less than or equal to 3 comma 1 less than y and less than or equal to 3? So this is nothing but we are the range of y is nothing but 2 comma 3 now. So what are the different possible values here? So I'll just write it here. P of x equal to 1, y equal to 2 plus p of x equal to 1, y equal to 3 plus p of x equal to 2 and y equal to 2 plus p of x equal to 2 and y equal to 3 plus p of x equal to 3 and y equal to 2 plus p of x equal to 3 and y equal to 3. So if we substitute all the values here, so we'll have 5 by 54 plus 7 by 54 plus 6 by 54 plus 8 by 54 plus 7 by 54 plus 9 by 54, and now that is nothing but 42 by 54, this is 4, and that is nothing but 7 by 9. Next question. So we have a joint distribution of x and y. We have to consider the random variable x z is equal to x square of y. So we have to find the range of z given y is equal to 2. Right, so to do that, first we have to find out the value of k. So as you know, we just have to sum up all these things and we have to equate that to 1. So that is nothing but sigma fxy is equal to 1. That is nothing but k plus k, 2, 2 plus 2 4, 4 plus 2 6, 6 plus 4 10, 10 plus 3 13, 13 plus 1 14, 14 plus 6 20. That is 20k is equal to 1. It means that k is equal to 1 by 20. Right. So now for the range of z given y is equal to 2. So that is nothing but if y is given 2, it means that we'll have to consider this particular row. And now what are the different ranges of z here? So z will have x square y. Z is nothing but x square of y. So that is nothing but 1 square into 2, that is 1 square into 2 comma 2 square into 2 comma 3 square into 2. Now tz given y is equal to 2 is nothing but, that is 2 and this is 2 square 4, 4 2s are 8, and now this is 3 square 9, 9 into 2 is 18. Now this, the probability of z is equal to 2 is nothing but 0, right? So this column, this particular guy, so we can say that the range of z given y is equal to 2 is 2 comma 18. Next question, find the value of p of z equal to 18 given y is equal to 2. So that is nothing but p of z equal to 18 comma y is equal to 2 divided by p of y is equal to 2. and now that is equal to p of x equal to 3 comma y is equal to 2. So remember that we get 18 whenever we have x equal to 3 and y equal to 2, right? 3 square into 2, that is nothing but 18. So divided by p of y is equal to 2, that is equal to 4 by 20 divided by 6 by 20, and now that is equal to 4 by 6, and now that is equal to 2 by 3. Next question. Right, so from a sack of fruits containing 3 mangoes, 2 kiwis and 3 guavas, a random sample of 4 pieces of fruit is selected. If x is the number of mangoes and y is the number of kiwis in the sample, then find the joint probability distribution of x and y. Now the total fruits is 18. Sorry, the total fruits is 3 plus 2 5, 5 plus 3 is 8. Okay, now x, that is the number of mangoes we can either have, we are picking only 4 samples, right? So we can get 0 1 2 and 3. And what about y can have y is nothing but the number of kiwis, right? So we have only 2 kiwis, so the possible number of kiwis can be 0 1 or 2. Now so these are the ranges of x and y. So let's see, can we get 0 comma 0? It means that in the final selection of 4 pieces we should not have any mangoes or any kiwis. Is it possible? No, because we have only 3 other fruits left. So total number of fruits that we are picking is 4. We'll either get 1 mango or 1 kiwi. Both 0 is not possible. That is nothing but f x comma y 0 comma 0 is 0, right? So now we'll start with p of x equal to 0 and y is equal to 1 is nothing but, so how many mangoes are we picking? We are picking 0 mangoes. So how many kiwis are we picking? We are picking 1 kiwi, and we are picking 3 guavas, right? 3c3 divided by total number of fruits is 8. Out of 8 we are picking 4, right? So this is nothing but 2 by 70. So the next one is p of x equal to 0 and y is equal to 2 is nothing but 2c2 into 3c2 divided by 8c4, and this is nothing but 3 by 70. The next one, p of x equal to 1 comma y is equal to 0. Now we are picking 1 mango, right? So 3c1, and we are not picking any kiwis, but we are picking 3 guavas. So 3c3 divided by 8c4. So that is nothing but, again this is 3 by 70. Next one, p of x equal to 1 and y is equal to 1. Next, that is nothing but 3c1 into 2c1 into 3c2 divided by 8c4 is nothing but 18 by 70. The next one, p of x equal to 1 comma y is equal to 2 is nothing but 3c1 into 2c2 into 3c1 divided by 8c4 is nothing but 9 by 70. Okay, the next one, p of x equal to 2 and y is equal to 0, and that is equal to 3c2 into 3c2. So the first one is for the mangoes, the second one is for the guavas. 8c4 is equal to, again this is 9 by 70. So p of x equal to 2 and y is equal to 1 is nothing but, we are picking 2 mangoes and we are picking 1 kiwi and we are picking 1 guava divided by 8c4 is nothing but 18 by 70. Now p of x equal to 3, so x equal to 2 and y is equal to 2 is nothing but 3c2 into 2c2 divided by 8c4, and that is nothing but 3 by 70. Right, so p of x equal to 3 comma y is equal to 0, so that is nothing but 3c3 into no kiwis, so 3c1 divided by 8c4 is equal to again 3 by 70. Now p of x equal to 3 and y is equal to 1, this is nothing but 3c3 into 2c1 divided by 8c4, and that is equal to 2 by 70. Again p of x equal to 3 and y is equal to 2 is not possible. So if you need, we can write this in a neat box. X and y, x takes the value 0, 1, 2 and 3, and y takes the value 0, 1, 2 and 3. I'll just use a different color for all the borders and all. Right. So we have 0, 3 by 70, 9 by 70, 3 by 70, again 2 by 70, 3 by 70, sorry, this 3 is not here, okay, and we have 18 by 70, 18 by 70, 2 by 70, okay, 9 by 70 and 3 by 70, and this is 0. Okay, next question. I have suppose you flip a coin. If the coin lands head, you roll a fair 6-sided die 50 times. If the coin lands tail, you roll the die 51 times. Let the x be 1 if the coin lands on head and 0 if the coin lands tails. Let y be the total number of times you get the number 5 while throwing the dice. So find probability of x equal to 1 given y is equal to 10. So x equal to 1 meaning that we have heads on the coin toss, and y is equal to 10 meaning that out of 50 such roll of dice we have to get 10 times number 5. Okay, so how to do this? So this is nothing but, if we write this in the form that we know, p of x equal to 1 comma y is equal to 10 whole divided by p of y is equal to 10. Now so p of y is equal to 10. So to find this is not so easy, so we'll write this in different form. So it's nothing but, I'll send this to the left hand side, that is equal to p of x equal to 1 given y is equal to 10 into p of y is equal to 10 is equal to p of x equal to 1 comma y is equal to 10. I'll call this equation 1. So again I'll go with p of x equal to 0 given y is equal to 10, and now that is again given by p of x equal to 0 comma y is equal to 10 divided by p of y is equal to 10. Again I'll I'll send the p of y is equal to 10 to the LHS. Now I'll have p of x equal to 0 given y is equal to 10 into p of y is equal to 10 is equal to p of x equal to 0 comma y is equal to 10. I'll call this equation 2. Okay. Now I'll reverse this and I'll say p of y is equal to 10 given x equal to 1 is nothing but p of y is equal to 10 comma x equal to 1 divided by p of x equal to 1. And now I'll do the same thing. P of y is equal to 10 given x equal to 1 into p of x equal to 1 is nothing but p of y is equal to 10 comma x equal to 1, and I'll call this equation 3. Now similarly I'll have p of y is equal to 10 given x equal to 0 into p of x equal to 0 is nothing but p of y is equal to 10 comma x equal to 0, and I'll call this equation 4. And now I can write that p of x equal to 1 given y is equal to 10 into p of y is equal to 10 is equal to p of y is equal to 10 given x equal to 1 into p of x equal to 1. Right, again, so p of x equal to 0 given y is equal to 10 into p of y is equal to 10 is nothing but p of y is equal to 10 given x equal to 0 into p of x equal to 0, and I'll call this 5 and 6. And now I'll do equation 5 divided by equation 6. I'll have, if I divide this, p of y, this term will be cancelled, so what's remaining, so p of x equal to 1 given y is equal to 10 divided by p of x equal to 0 given y is equal to 10, that will be equal to p of y is equal to 10 given x equal to 1 into p of x equal to 1 whole divided by p of y is equal to 10 given x equal to 0 into p of x equal to 0. And now, so we know that this, since it is a fair die, it means that these two value will be equal to 1 by 2. So p of x equal to 1 and p of x equal to 0 is 1 by 2. Now, so this is nothing but a binomial, right? So we are repeating the roll of die 50 times. So here, out of 50 times in the numerator, so we have to get 10 times, right? So into the probability of success, the probability of 5 is nothing but 1 by 6 to the power of 10 into 5 by 6 to the power of 40 whole divided by into 1 by 2 is there. And now 51 divided by 51c 10 into 1 by 6 to the power of 10 into 5 by 6 to the power of 41 and into 1 by 2. 1 by 2, 1 by 2 is cancelled. 1 by 6 to the power of 10, 1 by 6 to the power of 10 is also cancelled. And now we'll have 41 divided by 51 into 6 by 5. So here, upon simplifying, we'll get 82 divided by 167. Now, next question. sorry, this is not 82 divided by 167, this is 82 divided by so this is nothing but 82 by 85, right? So we have to find out P of x equal to 1 given y is equal to 10. So that is nothing but 85 divided by, sorry, 82 by 85 into P of x equal to 0 given y is equal to 10. Now upon simplifying this, we'll have P of x equal to 1 given y is equal to 10 is nothing but 82 by 167. Okay, question 10. So we have 3 balls are selected at random from a box containing 5 red, 4 blue and 3 yellow and 6 green colored balls. If x, y and z are the number of red balls, blue balls and green balls respectively, choose the correct options among the following. Okay, so we have plenty of options, so I'll just write here. So number of red balls are 5, number of blue balls are 4, yellows are 3 and greens are 6, and now the total number of balls are 18. Okay, so x is nothing but red ball, y is nothing but blue balls, and z is nothing but green balls. Okay, so 3 balls are selected. Okay, so the first option is nothing but P of x equal to 1 comma y is equal to 0 comma z equal to 2, and now this is nothing but in the denominator we'll have 18c3, right? So red balls are 1, it means that 5c1, y is 0, forget about blue, and now z is 2, that is 6c2. So 1 plus 2 is 2, so 1 plus 2 is 3, so we'll have total number of balls selected is 3, and upon simplification we'll have 25 by 272. Okay, our second option, probability of x equal to 1, y is equal to 1 and z equal to 1 is nothing but, so we are selecting 1 from the red balls and 1 from blue ball and 1 green ball, 6c1 divided by 18c3, and this is nothing but 5 by 34. Okay, the third option is probability of x equal to 1, y is equal to 0 and z is equal to 2. Now we have already seen that since the first option is right, so this option obviously will be false. This will not be equal to 1 by 4. Okay, the last option is probability of x equal to 0, y is equal to 0 and z is equal to 3. All the 3 balls selected is green, so that is 6c3 divided by 18c3, that is nothing but, and that is nothing but 5 by 204. Okay, so next question. A computer system receives message over 3 communication lines. Let xi be the number of messages received on the line I in 1 hour. Suppose that the joint PMF of x1, x2 and x3 is given by f x1 x2 x3 of x1 comma x2 comma x3 is equal to 1 minus p1 into 1 minus p2 into 1 minus p3 into p1 to the power of x1, p2 to the power of x2, and p3 to the power of x3 for x greater than or equal to 0, and x2 greater than or equal to 0, and x3 greater than or equal to 0, and this is less than or equal to 1. Okay, so now what is given here? So we have to find out p of fx1 x2, right? So how to find out px1 x2? So we have to sum over x3, right? So this is nothing but sigma x3 is equal to 0 to infinity. So we have to find out x1 x2 and x3 of x1 comma x2 comma x3, and now that is nothing but sigma x3 of 1 minus p1 into 1 minus p2 into 1 minus p3 of p1 to the power of x1 into p2 to the power of x2 into p3 to the power of x3. So I'll take out all these terms outside, so that is nothing but 1 minus p1 into 1 minus p2 into 1 minus p3 into p1 to the power x1 into p2 to the power of x2 into sigma x3 of p3 to the power x3, and now that is nothing but, so sigma x3 of p3 to the power x3 is nothing but, so if I go on substituting the values of x3 from 0 to infinity, so if I substitute 0 I'll get 1 plus, next if I substitute 2 I'll have, if I substitute 1 then I'll have p3, if I substitute 2 I'll have p3 square, and so on. And now what is the sum of this? This is a geometric progression where the first term is 1 and the geometric ratio is p3, right? So the sum is given by first term divided by one minus p3, that is 1 minus r. So substituting this back here, we'll have f of x1 x2 of x1 comma x2 is nothing but 1 minus p1 into 1 minus p2 into p1 to the power x1 into p2 to the power x2. So next question, find px2 of x2. So we already know the value of px1 x2 of x1 comma x2, and that is nothing but 1 minus p1 into 1 minus p2 into p1 to the power x1 into p2 to the power x2. So if we sum over x1, so that is nothing but sigma x1 of 1 minus p1 into 1 minus p2 into p1 to the power x1 into p2 to the power x2. So I'll take 1 minus p1 minus 1 minus p2 into p2 to the power x2 outside. I'll have sigma x1 of x1 of p2 to the power x2. Again similarly I'll have 1 minus p1 into 1 minus p2 into p2 to the power x2 into 1 by 1 minus p1. So this term is cancelled. So what's remaining is 1 minus p2 into p2 to the power x2, this option, right? So finally they're asking us to find out p of x1 is equal to 2 and x3 is equal to 5. So this is nothing but f x1 x3 of x1 comma x3, and this is nothing but following the similar derivation we can find out that 1 minus p1 into 1 minus p3 into p1 to the power x1 into p3 to the power x2, p3 to the power x3, and this is nothing but 1 minus p1 into 1 minus p3 into p1 square into p3 to the power 5. So next question. A coin is tossed twice. Okay. The x is, let x denote the number of heads on the first toss and the y denote the number of heads on the two tosses. If the coin is biased and the head has a percentage of 40% occurrence, that is nothing but p of head is 0.4. Okay, so what can I get as the value of x? The range of x is nothing but I can either get 0 or 1 number of times in the first toss, right? Either I can get 1 time or 0 times. So here the probability of getting 0 is 0.6 and probability of getting 1 is 0.4. Okay, what is the probability of getting y? The range of y. Total 2 tosses, we have 2 tosses. The total number of heads in the 2 tosses. Either I can get 0, 1 or 2. Right, so what are the different outcomes that I have? I can get head, 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 tail, tail, head, and tail, tail. There are only 4 different outcomes. Now I can write out the entire joint distribution, right? So y and x 0, 1 and 0, 1 and 2. Okay, so tail and tail. So if I have tail on the both, I'll have 0.6 into 0.6 and that is nothing but 0.36. And now 0.6 into 0.4, and now wait, so this cannot happen, right? So if I already have x as 1, that is I'll have head on the first toss, I cannot get y as 0, right? So this possibility is not possible. So the next one here is y is 1 and x is 0. It means that in the first toss I'll get tail and the second toss I'll get head. It means that I have 0.4 into 0.6 and now that is nothing but 0.24. And then now next thing here is first toss I'll get the head and the second toss I'll get tail. Okay, because the total number of heads is 1, again 0.4 into 0.6, again same thing, 0.24. Finally this case is also not possible since the total number of head is 2. I cannot get tail on the first toss, right? So this possibility is 0. And finally I'll have head on the both cases, head and head, and that is 0.4 into 0.4, that is nothing but 0.16. Now 14th question, probability of y is equal to 2. Probability of y is equal to 2 is nothing but the summation of this particular row, that is nothing but 0 plus 0.16. The answer is 0.16. What is the probability of x equal to 1? X equal to 1 is nothing but I have to sum this particular column, that is 0.24 plus 0.16, that is 0.40. And now finally probability of x equal to 1 and y is equal to 1, that is this particular guy, that is 0.24. Now next question. Okay, so I have 3 different random variables, x1, x2 and x3, where the range of xi, any x is either -1 or +1. Okay, so I have to find out if they have given the fx1, x2, x3 of -1, -1, 1 is nothing but 1 by 8, fx2 of 1 is 1 by 6, fx3 given x2 is equal to -1 of 1 is nothing but 1 by 5. And also they have given f of x1 given x2 is equal to -1, x3 is equal to 1 of -1. So this is the term that we have to find out. Okay, now so this can be written, since this is a conditional probability, we can write that as f x1, x2, x3 of x1 is equal to -1, comma x2 is equal to -1, comma x3 is equal to 1 whole divided by whatever that is the condition should be in the denominator, that is f x2 comma x3 of minus 1 comma 1. So right, so this denominator can be written as, I'll just copy down the numerator, minus 1 comma 1 divided by, so I'll just write the conditional probability for this. Fx3, since this particular value is given, I'll write fx3 given x2 is equal to minus 1 of 1 into whatever that is the condition, that is fx2 of minus 1. So now substituting all the values that is given, 1 by 8 divided by 1 by 5 into 1 into, so I need fx2 of minus 1, but they have given fx2 of 1 is 1 by 6. So how to do this? So this is nothing but since x2 has only two values, minus 1 and 1, right? So here now, so one of this is given, the other one is nothing but 1 minus 1 by 6. So this value is 1 minus 1 by 6, and now that is equal to 1 by 8 divided by 1 by 5 into 5 by 6, and now that is equal to 3 by 4, and now that is equal to 0.75. Next question. Suppose the number of people who visit a yoga academy each day is a Poisson random variable with mean 30. Suppose further that each person who visits is independently a girl with a probability of 0.5 and a boy with a probability of 0.5. Find the joint probability that exactly 10 boys, 15 girls visit the yoga academy on any given single day. Right, so I'll just assign some variables here. Let x be number of boys and y be number of girls, and now we have to find out z as x plus y, total number of people visiting the center. So what is the first question? Probability of x equal to 10 comma y is equal to 15. So this is nothing but, I'll write this in terms of conditional probability. Probability of x equal to 10 comma y is equal to 15 given z is equal to 25 into probability of z is equal to 25. And now this is nothing but probability of x equal to 10 comma y is equal to 15 given z is equal to 25 is nothing but, since this is a Poisson random variable, right? So as you can see, the number of people visiting the yoga academy is a Poisson random variable. It is nothing but this z is Poisson of 30. Now, so this is nothing but, if we substitute e to the power minus 30 into 30 to the power 25 divided by 25 factorial. Okay. Now, so this particular guy, probability of x equal to 10 given y is equal to 15. Sorry, x equal to 10 comma y is equal to 15 given z is equal to 25 is a binomial, right? So if one of the person enters the yoga academy, either he can be a boy or a girl. So that particular thing repeats 25 times, right? So this is nothing but 25 comma the probability of success, right? So that is given 0.5. So this is nothing but 25 C10 into 1 by 2 to the power 10 into 1 by 2 to the power 15. So this is nothing but 25c10 into 1 by 2 to the power 25. Okay, so now substituting back here, so I'll have 25c10 into 0.5 to the power 25 into e to the power minus 30 into 30 to the power 25 divided by 25 factorial. And now that is nothing but, I'll expand this particular term, that is 25 factorial divided by 15 factorial into 10 factorial into 0.5 to the power 25 e to the power minus 30 30 to the power 25 divided by 25 factorial. 25 factorial gets cancelled, so what is remaining, that is e to the power minus 30 into, now, so since this is, we have the same power, this can be written as it is, that is 15 to the power 25 divided by 10 factorial into 15 factorial. Right, so thank you for watching. Consider like, sharing if you have benefited from this video. Thank you.